It helps then attach to the actual bacterial cell, injects its genetic code into the bacteria, where it uses the bacterial machinery to recreate itself and more copies of itself, so that all on the inside you get many, many copies of these new superhero viruses, which then burst out of their host bacteria, killing it. So where can we actually apply this type of therapy? Well, basically anywhere where these infections can occur and develop resistance. And this is just an overview to highlight that many different organs are predisposed to getting infections. We have an interest in the lungs. We can actually find that many different types of bacteria can infect different types of organs. I've highlighted the two that we are basically concentrating on here in WA, which is Pseudomonas aeruginosa and Staphylococcus aureus, as our initial points of target, because they have broad applications to treat infections. But we also are developing new pipelines for other different types of bacteria. Looking at bacterial phage and also where they occur, you also have to look at how you're going to deliver that bacteriophage as a therapeutic. And that's really going to be dependent on where the infection occurs. And I just wanted to highlight that obviously if you have a chest infection in the lungs, you would have to probably use a route of nebulized or inhaled bacteriophage therapy. If you've got something that's far more topical, such as a skin infection, you would tend to use a topical administration to deliver this particular phage. So delivery and administration is a very important key to this pipeline puzzle. When you want to look at it in a form of therapy, obviously it's going to be in a bespoke or precise kind of manner. And by that, I mean a patient who has developed antibiotic resistance obviously will have gone to a clinician to treat, to seek help for this. Ideally, in a translational pipeline, these bacteria will be cultured and sequenced and characterized to understand why they are resistant to current forms of therapy. Hopefully, there's a large library of bacteriophage that is available to be able to be screened, and then particular bacteriophages identified to be effective against them, and that's indicated by the red circles. We would then try and pipeline that, mix these together to make a phage cocktail, can be then delivered back to the person expressing or having this particular infection. So hot off the press as to how this was going, and this is something literally we got data off today that I wanted to share, which was really exciting, is that we were approached by our clinical colleagues here in Perth of a patient who had developed nearly full antibiotic microbial resistance against a Pseudomonas infection. So he was in for a post-operative, for an operation, developed complications and developed Pseudomonas aeruginosa as a result of infection. Within 4 weeks, he's developed multi-drug resistance and is only currently susceptible to colistin. So the prognosis in the long term is not looking very positive. We literally obtained an isolate at the end of last week and have been screening our bacteriophage library against this particular clinical isolate. We've screened 145 of our bank, and we've got currently over 2,000 in our bank to screen. And as you can see, yeah, we've grown this bug, which makes this nice lawn of sort of opaque growth on our culture dish. And then we dropped two identical droplets of each type of bacteriophage on this to test which ones would be active against killing this bug. And what we have found is that we've got over 40 that are active against this bacteria, some with strong activity that's indicated in the green boxes. And a number of these, 7 of them, in fact, with very strong activity where you can see very clear zones of clearance and killing of the bacteria. So this is extremely encouraging and showcases proof of concept that we can actually identify these bacteriophage or superhero viruses to treat these bacteria. Now, I'll go into this in a little bit more detail after Anna's talk, but we're creating a harmonised national effort to try and translate bacteriophage therapy into clinic. This is in partnership with major clinical lead in Westmead, Professor John Erdell in New South Wales. And basically, part of this is to nationalise or harmonise the national approach to translation. And we've got engagement from nearly every state in Australia who is in the bacteriophage therapy field. We all have our own interests in the bacteriophage and the bacteria that cause resistance. We all bring in our expertise in those particular areas, and we're going to go under a unified umbrella to treat all MDR infections with this particular approach. Our vision moving forward is through a national approach, we will have access to or created in-house libraries of these superhero viruses that we have available, as I've described with that clinical isolate. Also, through our international collaborations, we've got access to overseas libraries that we also can screen our particular bacterial isolates against if we have no libraries present in this country. There are two main applications that we are aiming for. In the short term, obviously precision treatment for particular patients who have developed multi-drug resistance to a particular isolate, where very similar in the example that I just mentioned, we will screen bacteriophage 4 and hopefully effectively treat these individuals. In the longer term, because of their tightly regulated process, we ultimately would like to have a normal standardised dispensary for bacteriophage to infections, and it will be treated more as a prophylactic, where we can treat far more people in a short period of time. They're dispensed through a pharmacy as standard medications, or you'll go into a phage clinic for particular treatments. However, being a biologic, obviously this is a very tightly regulated process, and the timeline for this would be a lot longer. So with that, I'm just going to thank everyone who has actually helped develop our pipeline here in Perth. And I will hand over basically to Anna now to continue on the clinical translation of bacteriophage therapy into clinical practice here in WA.
Thank you, Anthony. It's a really lovely talk. I'll just try to share my slide first. Okay, I just want to check we're all looking at the same screen. We're looking at the orange title page here.
I think you've got it in. You've got it in a viewer share mode. Yeah, not in presentation.
So let me just see what I should do. Hang on a sec.
To do it down the bottom.
Down the bottom, Anna, near the plus and minus sign.
Just to the left of the slider.
Sorry, hang on. The plus and minus sign.
Down the bottom, which is increasing this, where it's got notes down the bottom, and then it's got
we're talking about the PowerPoint slide.
Yeah, the PowerPoint.
Yeah. So I'm clicking on the one that says slideshow. Is that right? Or
yes.
Yes, that should be right.
Okay. And can you see the title page here, or you're seeing this share?
No, we're seeing the
viewer mode. Yeah, we're seeing the presenter mode, Anna.
Okay. All right. Okay. Let me just see. I can put it down here. Just bear with me for a couple of new share. Screen 1.
So if you go on the share. Have you got two screens?
I have got two screens. And what can you see now?
No, the same screen that you showed before.
Okay.
So if you I'm just trying to.
And what are you seeing? Are you seeing the presenter mode?
We're seeing your Teams page.
Sorry. No?
No, you're still on the Teams. You're still sharing the Teams screen. So if you've got the PowerPoint on that bottom of that screen, I can see that there.
Yes, I've got two screens. Let me just see whether I can move it down here.
And then share the other screen.
And what are you seeing the PowerPoint or are you seeing the Teams one?
Teams on.
Okay. And can you see my PowerPoint?
No,
No.
we can just see your Teams one. Maybe if you stop the share and then start again.
Okay.
Once you've got this one, yep, I can see your PowerPoint now.
You can.
Yep, but if you go to the bottom of your screen where it says notes, and then you're actually on the next one across, you need to go four icons across from notes.
Yep.
And click that.
That's a slideshow one.
Yeah, it should work then. Should do.
Yeah, that's what I've clicked, but somehow I think it keeps displaying the readers sort of you hang on.
It's displaying it in presentation mode. As in.
Okay. What about this? Can you see it now?
No, it's still the same.
Okay.
We can see the slide you want to show though. I mean, it's just a bit smaller.
It is really tiny. I'm not sure why this is the problem. So, okay.
There you are. You've done it.
Have I done it now?
You've done it now.
Yeah. Okay, great. I don't know what I've done. So sorry everybody for the hiccup. And so yeah, I'm Dr. Anna Tai. I'm clearly not very savvy with the Teams, but I hope my presentation would provide you with some information apart from the amusement just now. So I would like to thank Anthony for all the great work his team is doing at Telethon Kids Institute. It's phenomenal amount of work they've put in the last 12 months. And the phage bank of more than 2,000 phage provides us with a really large weaponry for fighting multi-drug resistant organisms. And today I'd like to focus on Pseudomonas aeruginosa, which is a very important organism that Anthony has referred to earlier on. So Pseudomonas, what does it look like? Well, you can see on the right upper corner that little or the purple rods, and that's what they look like under the microscope. They're tiny and they live everywhere. They're in the soil, they're in the water, they're on plants. They're what we call ubiquitous, they're everywhere. But in patients who've got a susceptibility or underlying risk factors, they can cause major, serious human infections. And what's different and difficult about this organism is extremely clever. They're highly versatile, and that's the reason why they can adapt to so many different environments. But they're also intrinsically, they're born resistant to a whole lot of antibiotics we have in our cupboard. And what's more scary is that they rapidly gain resistance over time very, very quickly. As highlighted by Anthony's patient just now, I think it's within 2 weeks of the patient having that wound infection, that organism, if not eradicated, quickly learn to be resistant to everything else that they've been given. So they become increasingly difficult to treat. And so I just want to highlight the types of infections the same organism can cause in human beings. So firstly, people with underlying chronic lung disease, or if the immune system can't fight bacteria properly, they're particularly at risk of very severe infection. So Pseudomonas can cause blood infection, diabetic foot ulcer, and it can be so serious that if we can't get rid of the bacteria, the infection can eat into the bone, causing osteomyelitis. And if that's untreated, then patients lose their limb, basically, because of refractory severe infection. As a respiratory physician, we struggle with Pseudomonas infection, particularly in those who've got chronic lung disease, such as cystic fibrosis or bronchiectasis. And Pseudomonas is an important cause as a superinfection for patients who are in ICU, intubated, ventilated. It is a common cause of ventilator-related pneumonia. So I'd just like to introduce cystic fibrosis. Cystic fibrosis is one of the most common life-limiting genetic conditions in Australia. It is common and it affects 1 in 2,500 live births among Australians. So in other words, 1 in every 4 days, a child is born with CF. And CF affects multiple organs, but the most important organ it affects would be the lungs. It causes permanent destruction of the air tubes very, very early on. So kiddies born with CF, they are exposed to a whole lot of drugs and they're required to receive very intensive treatment to keep their lungs as clear as possible from infancy onwards. And invariably, as patients get older, they're left with chronic lung scarring. And many young adults proceed to needing oxygen or lung transplant very early on as a result of this relentless process. So this is the standard CF treatment for a child born with CF. They're required to do a lot of airway therapy every day. They're on a lot of medications. And over time, they're exposed to many, many courses of antibiotics. And they can take the form of pills, prolonged antibiotic intravenously, and they're required to do the airway clearance on a regular basis. And in spite of such aggressive screening and treatment, to date, and this is the latest data from the Australian CF registry, 80% of our Australian adults with CF remain infected with Pseudomonas aeruginosa. So as you can see, this is the age on the x-axis, and that's the age of the patients, and y-axis represent the prevalence of these organisms. And Pseudomonas aeruginosa, represented by this dotted green line, increase as patients get older, in spite of the diligent, intensive, protracted antibiotics they receive. I think the most likely reason for this is because the CF lung is so damaged, and Pseudomonas is in the environment. We can't ask our patients to live in a bubble. So upon exposure, patients acquire and subsequently are infected with Pseudomonas. And I just also want to highlight, CF is just a prototype. It is an example of how important infection can be an issue in patients with any types of chronic lung disease. Because you can see it's not just Pseudomonas that can get into someone's lungs who's quite damaged. And in the case of CF, patients are very often affected by different organisms on the right-hand side. I shall not name all of them because just spelling out the name takes a long time. But the key issue is that all these organisms, they are multi-drug resistant. And a lot of these organisms affect not just patients with CF, they affect patients with non-cystic fibrosis bronchiectasis, a very similar process, chronic obstructive airways disease, and of course, they can cause community-acquired pneumonia. And particularly in patients who are immunosuppressed for whatever reason, they can be an important cause of serious sickness, and they're extremely difficult to treat, highlighting the importance of having a weaponry against these organisms apart from just antibiotics. So just coming back to Pseudomonas aeruginosa, and we've done a study of the pattern of resistance of Pseudomonas locally in Western Australia among our adult cystic fibrosis population. So, and I just would like to acknowledge the Glenn Brown grant that enabled us to collect a large biobank of Pseudomonas. And what we did is we really asked the question, okay, do we have a problem? Do we have a problem with multi-drug resistant Pseudomonas in our clinic? So what we've done is we collected about more than 400 Pseudomonas isolates from 85 of our current adult patients attending our clinic. And what we've done, I just want to explain this graph. It's very, very bright. I just hope you don't mind. So on the x-axis, you can see the little acronyms at the bottom, but essentially they're the 12 most commonly used antibiotics to treat Pseudomonas in our clinic. And the y-axis is the percentage, and I shouldn't really include it 120% there, but it's there, and this is a mistake. But the key here is that you can see for the 400 odd isolates, when we tested the pattern of resistance to all 12 antibiotics, more than 50% of these isolates above here are resistant to all these 12 commonly used antibiotics. And the only antibiotic that's retains some kind of efficacy is just colistin. So I've basically boxed these antibiotics into groups. And the first box represents the beta-lactam, which is a very important group of antibiotics that were used in Pseudomonas. And interestingly, in the middle bit is ciprofloxacin, levofloxacin. That's the only class of antibiotic available as an outpatient treatment for patients with Pseudomonas CF lung disease as an outpatient. And you can see more than 50% of the isolates are completely resistant to our only oral option. And of course, when we look at the more commonly used aminoglycoside, again, more than 50% of our isolates tested were resistant to them as well. We do have a problem. And what's more challenging is that as patients get older, antibiotics have their own set of side effects. So patients are often intolerant to the antibiotics because of toxicity or allergy. On one hand, we've got superbug severe infection. On the other hand, patients might not be able to tolerate the few antibiotic that's effective against the superbug because the antibiotics would have already caused some damage in the hearing, kidney damage. For example, long-term tobramycin exposure causes cumulative toxicity in the kidney. So once past a certain point, the person will no longer be able to receive tobramycin or similar medications because the kidneys would pack up and go into renal failure. Skin rash allergy, it is very, very common. And it goes without saying that antibiotic disrupts the gut flora. And a lot of patients suffer from severe bowel symptoms and even life-threatening gut infection as a result of the antibiotic that we give. So antibiotic, on one hand, we're running out of options given the bugs are becoming more resistant. On the other hand, the host, as they get older, we're running out of options as well. So we're in a bit of a bind with a multi-drug resistant bacteria situation, particularly in adults. If you come to our ward, if you're one of our doctor team, when we chart our medications for patients with chronic lung disease, it is indeed a big challenge. When we chart what the patient's allergic to, or we can't, what types of drugs we can't give. And that box far exceeds sometimes the drugs we have at hand. And it's quite alarming. And that's the reason why we need new therapies apart from antibiotics to treat these bugs. So I won't go into phages a lot because I think it was very clearly and elegantly explained by Anthony earlier. But I just think of phages as bacterial viruses that effectively target and kill bacteria. And they're actually very widespread, used in widespread fashion in the pre-antibiotic era. And the current United States National Institute of Allergy and Infectious Disease has actually coined it as one of the 7 weapons against superbugs. So for my understanding, I just want something very clear for me to understand, well, why phage can they be used together with antibiotics? So I look at antibiotics as a big nuclear bomb. So once it goes in, it has a lot of collateral damage. It kills bad bugs, but it also causes a lot of disturbance or even elimination of good bugs, particularly in the gut. And that's why people get diarrhea. Whereas phages, they're like a missile, they're very targeted. They go in and zone into a particular organism you want to kill, and it just lies it and kills it. Whereas the antibiotic would cause a wide-scale damage, phages just kill the bugs that you targeted or designed it to kill. Antibiotics, by definition, they're ineffective against multi-drug resistant superbugs. Whereas phages, they're effective against both treatable, i.e. susceptible bacteria and superbugs. Antibiotic basically is the cause for antimicrobial resistant superbugs. Whereas phages, they're found in nature, they're non-toxic to animal, plants, and environment. And the good news is they're not mutually exclusive. They can be used hand in hand to attack the bacteria at different angles. So they can be used in synergy and should be used in synergy. So one key question that rises in my mind, because I've not used phage, clearly that's not something that we use currently. The first question I have is, are they safe? So firstly, there's a very long track record of human use of phage from 1917 when it was first isolated. And for the 100 years on, oral, intravenous, and topical phage have been used for various indications: diarrhea, gut infection, skin infection, chest infection. And since the rise of the antibiotic era around 1938, because antibiotics are so widespread, they're so powerful, bacteriophage therapy have largely fallen on the wayside in the Western world. But it continues to be used in the Eastern European, particularly in Soviet Union. And the clinical success is between 50 to 69% when used on its own. So a large part of these sort of phage therapy that's been used historically predate evidence-based medicine, and we don't have a lot of clinical trial data to inform us of the success rate, apart from a few clinical studies, which I'll quickly summarize and present. So historically, there are 4 key studies that's been reported of use of phage in firstly lung infection. The second study involved quite a large number of patients, about 300, more than 300. And the phage has been applied to skin, to lung infection, as well as wound infection. And again, the third study is describing a broad spectrum of infection. And the fourth study is looking at immunodeficient patients with recurrent infections. And essentially, of these large number of patients, there have been no significant side effects, apart from one single case of serum sickness in the patient who's immunodeficient. So basically, it's like a fever, arthralgia, or joint aches. It's like a flu-like illness. But apart from that, phage has been very well tolerated without side effects. And so it's more exciting to see that a systematic phage study has been sort of reinitiated in the recent times. And this is highlighted by the Phage-Burn study. It's a very small study in 25 patients with difficult wound infection. And what they did is that they prepared a phage cocktail and they rubbed it on the skin in the wound area. There has been no serious side effects. But the study is so small that it did not have any efficacy data to say that whether the phage add to the clinical benefit or whether there was not significant improvement. But clearly, the key message here is that when applied topically, it is quite safe and there's been no reported side effects. So what about in airways disease? What has been done? And specifically in cystic fibrosis or CF-like lung disease, how safe is it? So, and I've summarized the 4 published studies. They're really small, and you can see the first 2 studies are mainly N=1, which means it's just 1 patient study. And the third study involved 8 patients. So phage has been given for multi-drug resistant Pseudomonas, either in intravenous, oral, or nebulized form. And in all cases, patients improve, and there have been no reported side effects. So the more important question we have also is, do we have any data on phage therapy in any other Pseudomonas lung infections, such as bronchiectasis related to other causes, ventilator-related pneumonia, or whether we have any data on chronic obstructive airways disease Pseudomonas infection? And we do not. We have drawn a blank on the data search. And that's really the area where research really needs to come into, is that we need to establish the efficacy very quickly for patients with all types of Pseudomonas infection in different subsets of lung disease. So this is a brief overview. And I guess in summary, there's good anecdotal data of about 100 years of phage use in humankind. And the recent studies have also demonstrated safety of phage use in either when it's used topically, inhaled, or intravenously. Our key question really from our group is, can inhaled phages be used to treat Pseudomonas infection in cystic fibrosis or in any other lung condition or infection together with antibiotics? And this is our next phase of study, is to look at the phage therapy for adults with cystic fibrosis and bronchiectasis. We will be recruiting patients with both conditions through Sir Charles Gardner Hospital and Institute for Respiratory Health in conjunction with Telethon Kids Institute into the study within the next 12 months. And I'd just like to acknowledge this is a hugely collaborative effort between Sir Charles Gardner Hospital and Children's Institute that's just moved across the road a few years ago, and that forms a lovely bridge of collaboration. And I'd also like to acknowledge Sir Charles Gardner Hospital, University of WA, and relevant fundraisers, which has enabled our study to proceed. And I just particularly like to acknowledge Conquer Cystic Fibrosis Group, which has helped us initiate a lot of these studies along the way. Thank you.
Thank you, Anna. Thanks for that. Fantastic roundup of the clinical aspects with after Anthony talking about where we are and what it all means, and giving us a really good example of what phages are. Anthony, did you want to just finish it off with your words about future directions before we ask questions, or would you like the questions first?
No, I'll be about 2 minutes because I actually see a flurry of questions and want to actually open it up to the forum. But just as a natural segue, and I do apologise, Steve sends his apologies. He's the director of the Walyaan Respiratory Research Centre here at Telethon Kids Institute, who was going to present this next phase of our work. But we will do that. Anna, can you stop sharing your screen if possible?
Sorry.
That's right. No. Okay.
Hang on. I will post share. How's that? Is that better?
Yep.
I'm so sorry.
It's okay. No, it's okay.
Very
You just
sorry.
hold...
And I'll mute myself.
All good. All good. So, oops. Okay, so this is just one screen, and as I mentioned in my earlier presentation, Phage Australia is trying to is an entity that has been established through a lot of partner independent research groups that are all focusing on their own relevant areas of phage therapy. So under this leadership of John Odell, each state has their own node leaders. And here in Western Australia, Stephen Stick and myself are leading the WA Phage Task Force and the research areas into this particular area. Each state, as indicated on the left-hand side, will bring their area of research expertise in their particular bug of interest. So you've heard tonight that we are really focusing on Pseudomonas aeruginosa, but what we haven't presented is that we've got a phage library bank for Staphylococcus aureus, and we're developing for a few others, including Acinetobacter, NTM, and Klebsiella pneumoniae, to name a few. We have, through the Phage Task Force, identified at least 10 bacteria that cause resistant issues for clinicians through our health institutes here in Western Australia, and we're prioritising to develop pipelines for each of these bacteria. These are in partnership with other state nodes that are indicated in different colours, who also have different areas of interest in bacteria. These include E. coli, they can be Enterococcus, etc. So by connecting us all, we have the ability to reach to our collaborators to develop and address multiple bacteria infections and address particular therapeutic and research questions. Harmonising this particular approach and how we translate it into clinic, as Anna described, we need to develop two main areas. We need to develop phage libraries, as I've mentioned, both by harmonising how we isolate them and characterise them here in Australia, and also how we can acquire them through our international colleagues and collaborators. We also want to be able to use that to discover innovation in clinical trials, which is where we can get that translational hard evidence that Anna was advocating, that will help us actually translate it to particular clinic. So from that, we've got obviously many different aspects, and some of these are particular questions that have arisen. So one of these things is, once we've got these libraries, how are we going to prepare them to be able to translate them for clinical use? As you can appreciate, drug manufacturing is very highly regulated and requires particular manufacturing processes that are for good manufacturing processes, or GMP. And you need to have these particular this particular capacity to be able to manufacture them for translation. This is one of the stumbling blocks here in Australia because we don't have such a facility. And it's one that we're currently advocating and trying to address via, firstly, the need from our clinicians to illustrate the capacity that we can have this industry here in Australia, and not go to the limited overseas facilities for manufacturing at huge cost. This might be associated with particular industry partners or commercial partners. And we have already, as part of the Phage Australia network, had many conversations with a number of industry manufacturing plants that have expressed interest to look into this and partner with us for manufacturing capacity. Obviously, once they are actually compliant with regulation or guidelines that clinicians can administer to their patients, it's a capacity to actually then get healthcare providers on board to enable subsidised administration, rather than some of these highly specialised treatments that cost an arm and a leg, basically, at the end of the day, and in the long term may not be sustainable for many families that are affected. How we try and govern that here in Australia is really by combining our research and translational aspects and create an entity or a foundation for phage therapy. This will be a non-for-profit entity, and we hope to then be able to pipeline the researchers' phage libraries into this for administration for clinical trial and compassionate use cases, but also to facilitate the interaction with external partners and pharma that may want to actually conduct much larger phase 2 and phase 3 clinical trials. So that sort of gives a brief overview of really where Phage Australia and our efforts are being pushed in the next 12 months to establish this network. And I'll leave it there and open it up for questions. Some of them will be related to, obviously, the presentations made. So, Angela, did you want to facilitate the questions, or did Mitch you want to?
Yep, I'll do that for you if you like.
Okay.
Okay, hang on, I've just got to get them up. Okay, one person wants a copy of the slides if we can get them. So we can arrange that.
What we can do is provide that to Angela, and she can email a PDF to everyone that has attended tonight. So, yep, that's not a problem.
Okay. So I'm just getting down to the first slide. So somebody's on a learning curve, so their understanding comes from John to Jersey. So that's good. Question is, how long does phage work, and would it depend on the bug?
Yes, it will depend on the bug. Basically, you need to have a particularly identified bacteriophage against a bacteria for it to be effective. And some of them won't be effective and some of them will. And I think in my slide that I presented, at least with that patient isolate that we were screening, you could really see the differences in those kind of clear circles. You got some really strong positive missiles that Anna sort of alluded to, which really killed this bacteria, and some that were far less effective. From a therapeutic perspective, what we want to do is pick the most active ones against this, these particular isolates to use, and they will be the ones that we will translate. Phages, I think the first part of that was how quick do they work or how long do they work?
Yeah, how long is the average phage treatment, I think, is what they've
Phage treatment will depend on the type of infection that you go for. So looking into the clinical trials applications, you try and treat short, sharp and sweet. So you don't want long continuous exposure over long periods of time. This would be short administrations of about 15 to 30 minutes, either nebulized if you're actually inhaling, or it will be topical administration on, say, a burns wound or a leg ulcer, for example. You will then have that bandage or treatment changed twice a day, and then daily for a 14-day period, and then that will be your treatment period. It won't go longer than that. So we're looking at short, sharp exposure periods, because if you do expose over a continuous longer period, these bacteria can develop resistance against the phage, and that's what we want to try and avoid.
Right, okay. Another question was then about the costs of this, and like anything with costs is always one of the big questions. And the comment was, if it's seen as expensive, it'll be a political problem to get the funding and to continue the research, and then utilise it as a treatment. So I guess that's what you were talking about in terms of the partnerships and setting up the not-for-profit.
So that's it's a fantastic question and very astutely asked. It's one of the main biggest hurdles we've got here in Australia compared to many overseas countries. One, because we don't have the manufacturing capacity. So obviously the expense comes associated with sending our phages overseas to be prepared for human trial and then being sent back. There are about 3 or 4 commercial entities, 3 in Europe and 1 in the United States, that manufacture to GMP quality. And basically we've had a costing of at least €200,000 for one preparation and one treatment period only. So at the moment it is really expensive to prepare and actually treat for this. The way to counteract that is how I sort of described the need, by increasing not just targeted forms of therapy, but broad applications for many bacteria and many types of infections. We increase the capacity and the need to translate phage therapy. That will then reduce the cost because you've got capacity as a result of that. Secondly, we have also, as you mentioned, talking with commercial partners. That's where the full cost won't be borne by us in developing these kind of infrastructure and the actual industry that's needed to make these phage. And part of that cost can actually be incurred by the commercial partners, who may have already half the infrastructure established and only need the licensing and regulation certification to enable them to manufacture the phage.
Right. Okay. So it's that's certainly not it's not a simple thing to do, but we're certainly
no. I think it's one of the long processes, and we needed to start that now in order to make that translation much easier and much more possible.
Great. One of the other questions was, do you use phage in combination with antibiotics? And I think, Anna, you mentioned that yes, you can.
Yes, I think in the cases that's been studied, and I think including the, so I think Anthony mentioned this 15-year-old kid in the US who's actually got CF and Mycobacterium abscessus infection post-transplant. It was a major problem. She's got double whammy, and it was very difficult for her. And she initially started treatment with standard non-tuberculous Mycobacterium infection treatment. That's really harsh multi-drug treatment, and she failed to respond. And so then what they started using is intravenous plus rubbing the Mycobacterium, the phage on her wound. And of course she's got lung infection as well. So that basically continued for a period of time. So that would be the same duration as her antibiotic therapy. In the end, she cleared the Mycobacterium abscessus. So, and also for other cases, it's generally used in conjunction, not in substitution of the antibiotic. And I think for these bacteria that antibiotics do work to an extent, otherwise we won't be using antibiotics, but they're not the pure answer. And for these highly drug resistant bacteria, we really need and just attack it at both angles. And the good thing with phage is that it just recognizes whether it's a Pseudomonas. It doesn't really recognize whether it's multi-drug resistant or not. It sees the Pseudomonas, it zooms in, like what Anthony's, I love that picture. They inject the DNA and they multiply, and they basically lyse and burst the cell. So I think antibiotic would basically attack it another way, and they would either break the cell wall or stop the bacteria from replicating, or basically switch off the virulence or the toxin that the bacteria produce. So antibiotics not without use in multi-drug resistant bacteria. They're still of use, but they're not 100%. So that's why we need a 2-layered approach for these extremely difficult organisms. So we're up against a very formidable army and enemy. And I just think that if we're facing something like this, we need both rather than just one or another.
And I think I might add to that. That's great, Anna. There's some two unique kind of observations that we have found when we look at combining it with antibiotics. So one of these things is you can partner with multiple antibiotics. As it's not mutually exclusive, you can partner them with antibiotics. And what we found with some particular phage, you can use and effectively treat an infection at lower concentrations of both the antibiotic and the phage than if you try to treat them as individual targeted treatments. So as you can appreciate, if you've got a multi-drug resistant infection, you're going to use very high concentrations of antibiotics to try and treat it. You can reduce that antibiotic concentration if you partner it with a phage. And as Anna mentioned in her talk, there will be less side effects associated with that. Another unique feature around using phages in partnership with antibiotics is that sometimes the interaction between the three, as in the bacteria, the antibiotics, and the host, is that the bacteria can revert back to being antibiotic susceptible. So if it's full antibiotic resistant, these phages can actually manipulate the bacteria, and it tries to change and avoid it again, and in so doing loses these microbial resistant genes to try and change their characteristics, and as so become susceptible again to certain classes of antibiotics that they were resistant to before. So we can actually explore that in a kind of clinical fashion, that we can do these partnership assays and see whether we can actually try and trick these bugs to becoming antibiotic sensitive again as well.
Great. Well, that's another really positive, isn't it? So
yeah,
makes it easier to treat in the longer term and less toxicity for the person, so less side effects. Is fantastic. A question from Leon Brownrigg is repeat phage treatment possible, or do patients develop antiphage antibodies that make repeat treatment with the same phage less effective?
We don't develop antibodies against the phage. What will happen is if you continually just expose the bacteria to the one type of phage continuously and for a long period of time, the bacteria can evolve and develop resistance. So that's why I sort of illustrated in my model, you want to add a couple together to form a cocktail mixture. And how you make that cocktail mixture is making sure that you've got a nice diversity and different types of bacteriophage, some with a fatter head, a skinnier body, longer legs. They're all different types of the characterization that we want to partner together to then expose the bacteria to. So you can expose the bacteria, and the forms of treatment is repeated exposure to bacteriophage, but they have to be at short doses and with great diversity. And by that, then we can effectively clear infections.
Great. There's a question here that's, can phage therapy be used to treat osteomyelitis caused by Pseudomonas that has a resistance to antibiotics?
That's an Anna question.
An Anna question?
I think that, to be honest, I think if you've got a bacteria, you find the right phage, it will kill it, regardless of whether it's resistant or susceptible. It just doesn't recognize whether it's resistant, completely ignorant of what the bacteria displays. It doesn't really care. It just zones in and kills the bacteria, and that's what it does.
And so as long as
that's the lovely thing about it, you've got another way of going in and just addressing this bacteria.
It's just killing the bacteria. It doesn't matter. It doesn't actually worry about bacteria. Okay, great. A question from Robin is, how do you establish phage libraries? That's a you question, I think, Anthony.
Yep. Well, basically, as Anna said, they're ubiquitous in the environment. So we go out to look for slimy, stinky ponds, which basically stagnant water is the best way of collecting these. And you can also get it from wastewater treatment plants as well. So really, we go out in the height of summer, go to, stinky ponds around Perth, collect some water. We filter those and we actually screen them against a Pseudomonas phage or a particular Staphylococcus line, and then see if we get some positive hits. What we do then is purify those and make sure that they're stable and that they have good stability, because they are evolutionarily primitive, so they can evolve. And then once we've looked at that, we can test, and in partnership with Anna, she's been great to provide us with clinical isolates of these bacteria that are multi-drug resistant. So we can then look at how effective these isolated phage are against these clinical isolates. If they hold high activity or high efficacy against these clinical isolates, we then go through a more detailed characterization and look at their genetic code as well. And then we create a bank. So in creating our 2000 phage library against Pseudomonas aeruginosa, it's been pretty much nearly 15 months full on from our point of view. I have a team of 9 people working on this and in many different aspects. So there's a lot of man hours and there's a lot of effort and labor needed to do this. This is not a high throughput mechanized kind of machine process that you can put into a factory. At the moment, it's human orientated and it takes a lot of time. And I've still got students in the lab working behind me at the moment, so they're very dedicated. But what that has enabled us to do is amass a very big library in a short period of time that we can then now look at trying to translate into clinical practice. So in the long run, the high effort now and invested now will reap rewards sooner.
Fantastic. So we can see you in a swamp somewhere around Perth over the next few months then.
Yeah, I'm going on holidays in about a week and a bit, and I'm going hunting.
Right. All right. So Katarina's asked, there are many good bacteria in the gut and many more are being identified. Is it possible for a phage to inadvertently attack a good bacteria?
Anna?
I think it's we'll never say never, but I think the scale of destruction caused by the phage is so low. And I think when you look at antibiotics, it just completely changes the whole microbiome of the gut. And that's manifested in patients with cystic fibrosis, in that their gut's been altered. The gut microflora is completely altered by the antibiotic that's been given. On the other hand, what we know is that phage is actually used as oral therapy for people with gut infections. And that's been used in some countries. It's even used as an over-the-counter treatment for people with gut ailments. So what it does, it seems to restore some kind of balance within the gut microbiome. And one worthy question to look into is for oral forms of phage, what happens to the microbiome composition when they do take it? But I think just the nature of the phage is very specific. And it just identify a single host and it just zone in and kill it. So with the trillion of bacteria sitting in the gut, I just think that the ability of it to cause collateral damage is much lower compared to antibiotics. But yeah, I don't think there's been any data to date to look at the impact of oral phage therapy on the gut microbiome. I think that will be the study that needs to be designed to address your question then.
Right. Hopefully the missile approach is better than the nuclear
bomb.
Nuclear bomb, yeah.
Great. And can you use blood samples that have been stored that have Pseudomonas that is proven already to be resistant to antibiotics to help with the phage library, or is it just the stuff from the swamps?
No, so as we've sort of mentioned, phages are found everywhere the bacteria are. So if you've got a blood infection that has Pseudomonas, you will have phage located in them. So we can actually and have tried to isolate bacteriophage from biological samples, and that includes bloods, urine, sputum samples, phlegm, so to speak. And we've had some success. We've also had a look at breast milk as well, and we've had some positive hits from that. So you can use biological tissues. It really depends on how that tissue has been stored to see whether that bug can be grown, and then how stable the bacteriophage is as well. They tend to be stable more at lower temperatures, such as refrigerated temperatures, 4 degrees and -20. But if your blood has been frozen, for example, at -80, which is where a lot of our research material tends to be frozen, they tend to burst the bacteriophage. So it's highly unlikely that you may retrieve living phage off those samples. So it really depends on how it was stored and frozen.
Great, thanks.
But it is definitely doable.
Wow, that's great. That's awesome. So a colleague and friend of mine of long term, Anne White, has said, how will you sell this to the public, given some of the conversations taking place about vaccines for COVID?
I think we're starting in a great place here tonight, and the basis is about education and understanding, because obviously when you say viruses are good, a lot of people just don't, it doesn't hold hand in hand, and it's a very contradictory term. And so education from myself and clinicians like Anna helps to probably provide that education and that knowledge out into the community, that you can then go spread the word, and then at least the topic can be discussed within the community, and they can raise those particular questions with their own treating physicians or GPs down the track if you want to know more. Part of the ground roots is about selling it and selling the understanding. Selling it to the government is another thing. Selling it to the regulatory bodies is another thing. But however, we have engaged with the WA Health Department and the National Federal Government Health Department. They are very keen to see this explored in a lot more detail. So they are very open to actually this kind of technology and translational use. The regulatory body, which is the FDA equivalent, the Pharmaceutical Benefit Scheme, has already been open to discussions on seeing how this could be translated into a therapeutically identified entity and placed on the PBA if applicable in terms of that. So I think we've engaged with many stakeholders, both from the regulatory, clinical, like Anna, in terms of needs, and obviously grassroots people who actually have the infections. And there is knowledge and understanding out there. It's about getting everyone together and working the pathway to translation. And I think the more that we get to do these kind of clinical trials that Anna was talking about, the more people will be convinced, because they're conducted in Australia. They'll be very sound studies. A lot of the data will be tabulated and reported, and that can then be used for additional advocacy in selling it to the general public.
And I guess the other thing would be that as this goes along, what we'd be looking for is for getting consumer reference groups and groups who can support the work as well, to provide that, as you said, you've talking to the individuals with conditions, and then having advice from the community as well as scientists and clinicians, and to help sell to government as well.
Yep, absolutely. So part of the National Phage Australia pipeline is we're going for some major federal funding that we were shortlisted for. It's a $50 million call, but a large component of that application is really about consumer stakeholder involvement and endorsement. So we really need to work in partnership with both organisations and consumer reference groups that want to see this at least explored in a translational setting. So partnership with people like yourselves who have come out to listen tonight and may want to be part of the journey can easily sort of touch base with Mitch or Angela and basically become part of that process, and we can fit you in where we need you in terms of how we can, increase that advocacy, as well as the advocacy against to the funding bodies as well.
Great. See, we're getting some questions, so I'll just keep going through those. It's some fantastic questions.
Yeah.
How can you find out if you could be considered to be a candidate for the trials for phage therapy for a Pseudomonas that is resistant to antibiotics?
Well, I think what we're planning with Anthony as the first stage is clinical trial for patients with cystic fibrosis and bronchiectasis. Depends on the severity of the infection, because clearly if someone's got severe refractory lung infection, we can't wait for the clinical trial to take place. And in such a situation, then we need to look at compassionate access use of phage therapy in people who've got life-threatening infections. And I mean, compassionate access use of phage has been done in the eastern states, and it has been used in treatment in kids with severe osteomyelitis related to multi-drug resistant bacteria facing the fate of losing their foot. And in that particular situation, the foot was salvaged, the kid got better. And it has been used on a compassionate grounds for someone with cystic fibrosis. And again, very severe Mycobacterium abscessus infection that's refractory to toxic and difficult drug treatment. And for that person, they improved. So it has been used. It's not the first time we've used phage in Australia on a compassionate access type setup. And of course, the use of phage against not just Pseudomonas, but against Staph aureus has been well established and published by John Iredale's group in Nature. And I just think that this is a therapy. We are a little bit scared of it, unfamiliar with it. We don't know what to call it. Do we call it a drug? Do we call it a biological product? I think it's just some kind of all these complexity. But when it comes to really sick patient needing treatment, we say we want it. And so it depends on the situation of the person. If it's stable person, then we can a clinically stable person, then we can look at clinical trial. In someone who's desperately unwell, then to discuss with the clinician. We can always get in touch with the phage group and look at explore options. And we can obtain phage from Anthony's laboratory that's being generated, and it's just going to be identifying the best cocktail for that particular person, or other sources.
Yeah, and just to follow up on that, so as we sort of mentioned, Pseudomonas doesn't just infect the lungs, it infects wounds and so forth. So we have actually had talks with Fiona Woods, who is a burn specialist here in Australia and former Australian of the Year, to look at how we can treat antibiotic-resistant Pseudomonas infections in burns wounds, for example. We've also started discussions to look at skin infections in Indigenous children up north, which is caused by Staphylococcus aureus, and they cause chronic ear infections such as otitis media. So the bacteria that we're targeting from a lung point of view actually has many applications, and we're talking with infectious disease clinicians to see where we can actually target other clinical trials outside the lung space to try and get phage therapy up and running to treat other forms of infection as well.
There was one comment which was about researchers needing to educate people on what pure peer-reviewed science is and its efficiency in terms of getting information from Arthur. And Arthur also mentioned he'd like to give the PowerPoint presentation to a senior federal shadow minister. So,
please do.
There you go. So that will be available. Anne White again says, count me in, this is exciting. Katerina, maybe use the term phage, not virus, in promotion. Macrophages are taught to school students, so may be a familiar term for them. So, so using the phage, I think, is rather than talking about the virus.
Yeah,
it's a type of virus, but maybe that's it.
Yeah.
That's the end. I've got to the end of all the questions. Is there anybody else have a burning question they want to ask? It is argument time for he and I, and I've always been positive confusion. It's highly worthy, so great. Thanks, Arthur. If you've got another, anybody have a question, further questions? You've got 10 seconds, and I'm going to bring it, especially since we have taken up your time plus with our little glitch at the beginning. Thanks, Anne. I'd like to thank you all for your time and for sticking with us and coming over to the new link and asking so many wonderful questions. It's been fantastic, the questions. And as Anthony said, we are more than happy to keep you in the loop. If you'd like to be kept in the loop, let Angela or myself, I think you've all got Angela's email, let her know that you'd like to be kept in the loop, and we can work out how we can do that. And I'd especially like to thank Angela for arranging this and being in touch with all of you guys. Anthony, for your great presentations, and Anna, for your great presentations, fantastic answering of the questions, and thank you all, and good night.
Thanks,
you,
Mitch.
Thank you, everybody.
Just as a final thing, Angela might be able to send out just a short survey about particular questions that we could use for some advocacy kind of comments. And these about your interpretation of phage, your interpretation of whether it's safe, and so forth. And that can be used in terms of just sort of canvassing this particular group when we move towards that kind of understanding. So she's got everyone's email address and can actually set up that short, I think it's a 7 or 8 question survey. And then she'll be able to collate everyone's responses if you want to participate. So that will be great kind of initial feedback that this group can have.
Sorry.
Yeah, I'll send that out tomorrow.
Great.
Okay, thanks.
Thanks for
Angela.
tuning in, everyone.
Thanks all. Thanks. Have a great
Please.
evening.
Good
Thanks.
night, everyone. Thank
Bye.
you.
Yeah, everybody. Have a good night.
Okay.